Electric Motors Division General Motors Corporation Maintenance Instruction MI9109 Revision B Battery Charging Rectifier. Alright, description of the battery charging rectifier. Give the locomotive battery charging so that to permit the battery charging current to flow with the auxiliary generator to the battery, but prevents the current flow from the battery to auxiliary generator, alternator, fuel pump, motor, and electrical cap heater. Battery charging rectifier. Some of the consists of the match set of the silicone diode with a selenium suppressor rectifier mount with a heat sink with an assembly mount with an electrical cabinet with a circulation air cross with a heat sink that helps to keep the assembly safe with the operation. Suppression rectifier protect the diode with a reverse transit voltage spike with a permanent with the passage of the current reverse direction before the potential become with a high and altitude cause the damage of the breakdown current with the passage of the silicone diodes. Although the suppression rectifier protect with the diodes with a voltage spike with a ground fault during the locomotive with the high potential test can be set with a condition where the high potential is imposed across the battery charging rectifier called with the diode with the unprotected suppression rectifier to fail. If therefore recommended that the high potential test is made on the locomotive, the battery switch be open, the positive and negative terminals of the battery charge rectifier be jumpered to or together with the high potential test or the completed remove the jumper prior to the closing of the main battery switch. Maintenance battery charging rectifiers require no routine maintenance other than visual inspection. They should not be disassembled for inspection. Nuts and fastened diode heat sinks should not be disturbed. The nuts must be uniformly tightened to proper torque value without ensure the proper heating transfer inspection test. Auxiliary generator, alternator, fuse are blown upon the engine shutdown, and an extreme high rate battery discharge indicator of the battery charging ammeter or the engine shutdown failure of the battery charging rectifier should be suspected. Entire battery charging circuit of the battery charging rectifier should be inspected for defects. Battery charging rectifier, lantern battery test lamp with an ammeter testing for blocking. Good rectifier will conduct only with a forward black to red direction. Suppression rectifier, visually inspect the blistered paint points metal with a general symptom of the shortened suppression rectifier to determine whether the rectifier is working order. Connect 6-volt lantern battery series with the rectifier with a test lamp. Lamp should light when the battery is connected with the forward direction. Remain off the battery. Its reverse ammeter receive the check with the suppression rectifier. Rectifier should be first formed. Application at least 2 volts in both the forward and reverse direction a few minutes before the resistance is checked. Diodes. If the battery charging rectifier is faulty, the diodes must be disconnected and tested individually. Blocking characteristics faulty diodes must be removed and replaced by a matching diode with the diode. Matching number appear with the circle portion of the diode. Even if the diodes are not matched one over the parallel, diodes will carry greater current than the others will fail rapidly. If some of the reason mismatching diodes is suspected matching number is not legible, the diodes can be checked by the locomotive with the passing high current through the diodes as well when the charging low batteries. After approximately 15 minutes, one of the diodes will feel much higher than the other. Matched diodes will not differ in the temperature by more than 25 degrees. Removal of the replacement of the diodes rectifier. Assembly disconnect diode lead from the terminal place for the remove of the nut from the retaining ring. Figure 1. Inspect special diode socket wrench. Figure 2. Those excess hole. Figure 1. See infirmly on the hex portion diode. 3. Use box end wrench of the hot diode mounting nut while removing the diode. Show the terminal plate retaining bolt diode mounting nut and socket wart wrench access holes. Figure 1 battery charging rectifier assembly. Figure 2 shows special diode socket wrench, 1 1/4 inch hexagon special diode socket wrench, 1/2 inch driver cutout. Make certain socket is firmly seated in the proper seating stress of the crimped area during the torquing. Remove the diode from the heat sink. Remove all contaminants heat sink within at least 1.5 inch diameter circle around the diode mounting hole. Select matching diode. Refer to maintenance data with the type of the part number to apply with a thin coat with joint compound over the hex portion of the figure 3. Discolored marking varying ends of lug. Disregard color dot here. Serve the part number. Type 2 diode has red color band here. White ceramic indicates positive diode. Original equipment part number here. Silicone rubber combination boot and sleeve. Joint compound on hex base not on threads. Diode type number impressed on base of stud. Caution, do not apply with the compound with shove of the portion of the diode, specify the torque value of the dry threads, and solve the diode C-socket wrench firmly on the hex portion of the diode, apply with the torque hex portion of the diode, specify the maintenance data, connect with the diode, leave the terminal plate. Removal placement of the diodes rectifier slim with the major difference between the these rectifiers is the portion mounting bracket. Remove the glasstic side of the panel with the negative side of the rectifier, refer to figure 4, remove the 7/16 inch nut, remove 8 retaining screws, remove the nut for the suppression rectifier mounting stud, retaining screws, and show the selenium rectifier mounting stud glasstic side panel 7/16 of an inch nuts. 2. Carefully set the plastic side over the panel heatsink, remove the diode lead with a negative bus bar with an insert of the special side socket inside diode socket wrench figure 2 seat with firmly hex portion of the diode. Use the box end wrench to hold diode mounting nut while removing the diode. Caution, be careful to not damage heat sinks. 5. Remove the diode from the heat sink. 6. Remove the contaminant heat sink into at least 1.5 inch diameter circle around the diode mounting hole. 7. Select matching diode. Refer to mate and serve the data for the type of the part number. Apply thin coat with the joint compound over the hex portion diode figure 3. Caution, and apply the joint compound to the stud portion over the diode. Specify the torque value of the dry threads. Install the diode. Set the seat socket with a firmly hex portion of the diode. Apply with the torque hex portion of the diode. Specify the demand data. To reassemble the reverse order with the disassembly, make sure the negative lead of the compression rectifier is connected with the negative bus bar. Remove the replacement over the diodes rectifier assembly. Major difference between the rectifier with the position mounting bracket with the procedure of removal of the replacement of the diodes for the rectifier, essentially with the same procedure with the removal of the replacement of the diode reflectors 8319071, 8319692, with the major difference being with the rectifiers 8321535 and 8333596 containing 4 rather than 2 diodes. Side panels attached to the heatsink with within 16 rather than 8 retaining screws. Removal of the replacement diode rectifier assembly. The major difference between the rectifier position mounting bracket disconnect diode leave the negative bus. Remove the 5/16 of an inch 18 retaining nuts, lock washer, flat washers. Diode negative bus diode lead mounting stud suppression rectifier mounting studs retaining screws 8 inside panel. Distinguish lead lead from the red terminal of the suppression rectifier. Remove the side panel with the negative side of the rectifier. Removing 8, number 10, 16 of the retaining screw with the insert of the special diode socket wrench figure 2. The seating and the firmly with the hex portion of the diode. 5. Use the box wrench to hold the diode mounting. No, remove the diode. Question, be careful not to damage heatsink. Remove the diode from the heatsink. Remove all contaminants for the heatsink into at least 1/2 inch diameter circle around with the diode mounting hole. Select the matching diode for the maintenance data type of the part number. Apply thin coated joint compound under the hex portion figure 3 with the do not apply with the two compounds to show the portion with the diode with the specify the torque value with the dry threads. Install the diode seat socket with a wrench firmly with the hex portion of the diode. Apply with the torque hex portion of the diode. Specify with its maintenance data. Reassemble the reverse order with the disassembly. Be sure to reconnect the lead with the red terminal with the special rectifier. Remove the replacement diode with the rectifier assembly. 8416096, 8416192 figure 5. Major difference between the rectifier position mounting bracket with the procedure remove the replacement of the diodes for the rectifier. They're essentially the same when the procedure to remove the replacement diodes at 8416094, 8416095. Major just being the rectifiers 8416096, 8416192 containing 4 rather than 2 diodes. Side panels attached with a heatsink with 16 rather than 8 mounting screws. Bench testing, high potential test. Jumper red and black terminals rectifier assembly during test. High pilot assembly for 1 minute with a 600 volt RM at root mean squared between terminals mounting bracket. Bench testing diodes. Bench testing diodes performed with an extreme care with the testing circuit with the utmost importance to make sure that there's no transit voltage into the switching on and off. Use the test transformer with which the voltage gradually increase to 0 with the full value with the back out without switching is strongly recommended. Recommended test equipment. The following equipment is recommended for the testing diodes. The meter should be 2% accurate. Each of the piece of the equipment is identified. Reference designation number. Test circuit figure 6 and 7 inch valves. V1 average reading DC volt moving coil type of 0 to 1 volt. V2 root mean squared reading voltmeter iron value type 0 to 750 volt. I1 average DC ammeter moving coil type range suited to I2 average reading DC milliammeter moving coil type. CR1 equivalent test diode 500 PRV 400 mega amp leakage. CR2 100 PRV 0 225 mega amp leakage or 200,000 PRV at 25,000 leakage. Electrical requirements for the EMD rectifier assemblies. Forward voltage dropped across the assembly must not exceed 1.5 volt DC at 80 degrees Celsius with 160 amp forward current. Individual diode current should not exceed 88 amperes with 160 amperes total current into the rectifier assembly at 25 degrees Celsius. With suppression rectifier disconnected, 400 volt reverse voltage applied with the maximum lead current. Assembly should not exceed 24 milliamperes. Electrical requirements for the EMD rectifier assembly. Forward voltage dropped across the rectifier will not exceeding 1/2 volt DC at 80 degrees Celsius, 250 amperes forward current. Individual diode current should not exceed 68.75 amperes at 250 amperes. Total current rectifier assembly at 25 degrees Celsius. With suppression rectifier disconnected, 400 volt reverse voltage applied with a maximum leakage current with assembly should not exceed 48 milliamperes. Figure 6 show the reverse leakage test. The 75 volt one step up transformer, 75 watt capacitor voltage, voltmeter 1. Volt motor, volt 2, I2 controller, rectifier, bridge 2 diode must be tested. Figure 7 forward reverse voltage, 110 volt step down transformer, 1/10 of a watt transistor control rectifier on the other side of the 10 watt. Diode tested IM1, amp 1 voltage motor 2. Reverse leakage test rated to the peak of reverse voltage connected diode tested in circuit shown in figure 6. Test should be made at room temperature, maximum base temperature 150 degrees Celsius. Apply 280 volts root mean square voltage must be regulated. Observe the voltmeter 2 reading while under testing. The circuit must not enter over the diode with the test of damage into the reducer transient circuit voltage should be regulated 0. Specified voltage return to 0 before any of the circuit is disconnected. If the diode conducts more than maximum allowable reversible current at 10 milliamperes, the diode is defective and should be discarded. Forward voltage drop test. Connect the diode test with the circuit shown in figure 7 of the forward voltage drop. Meter and leads must be attached separately directly with the diode. Unattached with the input voltage upon current 3 with the diode. 70 ampere with the test must be limited to 10-second duration of the diode removed from the heatsink. 3. Forward voltage measured as a full cycle reading. Reading of the DC voltmeter half sin wave the constant circuit at room temperature. Maximum voltage drop across 52 hundredths of a volt DC. If the voltage drop exceeds these values, the diode is defective. Service data: maximum peak inverse voltage, maximum continuous DC voltage, type load, resistive, inductive, maximum ambient temperature 80 degrees Celsius, cooling temperature, convection, suppression, rectifier, RMSO option, operating volts, cleaning volts at 3 amp per peak current at 25 degrees Celsius. General information and part commands. Electric Motor Division, General Motors Corporation, maintenance instruction, battery charging, rectifier MI9109, revision B.